Hi, I'm Harry Powell from TigerGraph, the only scalable platform for analytics and machine learning on connected data. At TigerGraph, we talk a lot about how our graph database is super fast, and it is. 100 to 1,000 times faster than the competition in benchmark tests. But why does this matter? After all, surely I can just run the query overnight or buy a bigger computer. It'll be fine. Unfortunately, it doesn't work like that. The speed of a graph database query or algorithm is driven by slightly different factors than that of a normal database. Remember, a graph is a network of nodes, things, and edges, the connections between those things. Query speed is determined by 4 factors: the number of nodes you're calculating, the time the graph database takes going from one node to another, the average number of connections to each node, and the number of steps or traversals you want to make into the graph. Imagine you start at one node and that it is connected to 3 nodes, and each of those are connected to 3 more nodes, and so on. Then if it takes 1 unit of time to go along one edge, it will take 3 to make the first traversal, 9 to make the second, and 27 to make the third. Query time increases exponentially as traversals increase. But if you want an accurate answer to your query or algorithm, you have to explore as much of the graph as possible. You have to maximize the number of traversals. Now that means that the accuracy of the query is very sensitive to the speed of the database. If a slow graph database takes twice the time over one traversal, it'll take 2 to the 12 or 4,096 times longer over 12 hops. Now that's a lot. A 1-minute query becomes a 3-day query. What happens in practice is that the code just never returns a result, getting caught in a loop with an ever-growing stack. So, if you have a slower graph database, the only way to get a result out is to limit the number of hops in your query or iterations in your algorithm, and that means you can end up with wildly inaccurate output. Other graph databases are limited to around 3 to 4 steps on a typical query. That's really not enough. TigerGraph can comfortably do 12 or more. Speed is even more important in graph machine learning, where performance depends upon running a lot of iterations of the algorithm. TigerGraph is built from the ground up in C++ to be a hyper-performant graph database. It is the only graph platform that's powerful enough to do analytics and machine learning at enterprise scale and get results you can rely on. You can get a free 50 GB TigerGraph Cloud instance at tigergraph.com/cloud, or email me at info@tigergraph.com if you'd like to find out more.